As the nation turns its eyes upwards tonight in the spirit of celebration, I thought it would be a good time to take a look at another way our nation is constantly looking upwards in the pursuit of space domain awareness, and just how difficult that mission set really is. It's often easy for us to get lost in these orbital shapes and feel this sense of omnipotence that we always know where objects are going in space. But in this lesson, we're going to model the actual optics of a ground-based telescope looking up at orbital shapes like these to try to discern some appreciation for just how difficult this mission set really is. It's a lesson I like to call the optical illusion of space domain awareness. Okay, so just jumping straight into the scenario, we've got this reference satellite that's being observed by this ground-based electro-optical telescope. We're going to be looking through the telescope's sensor and trying to determine if we can figure out what are the orbital shapes that are occurring around this reference satellite. We'll see things like perches, linear drifts, nmcs, and some unique shapes. And our challenge today is to say, if we look just through this optical telescope, which will look something like this, what exactly are we seeing in this scenario here? Reference will always be at the center of the frame, and the lighting will change according to the actual lighting of the sun on the 4th of July, 2021. Let's dive in. Okay, this first one is super straightforward. You're going to see it play through the video twice. Reference is there in the center, and you're going to see when it fades into the darkness. I think it's pretty easy to tell that there's something that's not moving right next to it. Yeah, I'd call this pretty straightforward. What do you think? And sure enough, you are looking at a basic perch. Pretty easy, right? Okay, again, it's going to play through 2 times. Alright, what do we got here? Okay, see reference fading with another object over there. 24 hours of motion. Second playthrough. Yep, looks like it's just approaching reference at a constant rate. Yep, in this case, you're looking at linear drift. Straightforward, 1 degree per day, 78 kilometers, higher semi-major axis over 24 hours. Okay, what about this one? Looks like there's this object that goes away from reference, fades into the darkness, reappears to the right side, and then comes back to reference. Any guesses? Sure enough, that one was an NMC. So you can see we move out away from the target, and then we go directly above the target line of sight relative to the facility. We go out to the right of the target, and then we swing back through the center of the beam. Okay, let's try another one. A little bit harder. Kind of see the reference satellite area kind of growing and shrinking, growing and shrinking, growing and then shrinking again. What could this be? In fact, that was everyone's favorite force motion shape, the teardrop or DSK. Just directly over the target area, you can see just how difficult it would be for you to discern this with no depth perception. How about another one? Okay, lots of stars. Okay, it looks like there's something that goes above reference satellite, stops, comes back down when darkness, reappears below, and then comes back to reference satellite. Yep, you might have guessed it based on the direction of motion. That was obviously a cross-track, slightly eccentric orbit just for safety. You can see we never actually intersect with the reference frame. We're more in one of these twisted nmcs. Here's a pretty fun one. Okay, welcome to darkness. Alright, second playthrough. Yeah, you're seeing some cross-track motion, in-track motion, definitely something forced motion. What's this? Yeah, and this orbital shape is what we like to call a halo orbit. So we're about 50 meters and some change above the reference area, just doing one of these force motions in the cross-track and in-track direction to create this nice ring above the target area. Okay, last one, here we go. This is for all the points. Oh yeah, this is obvious. Yeah, you can see it's kind of like dancing over here, and it gets a little closer, does some dancing in the darkness, and then approaches. Very, very straightforward, this one. And our final shape, just in the spirit of celebration, was of course a USA written in space over 24 hours. Happy birthday, America.